Here we're going to take a look at hypotenuse leg triangle congruency. Hypotenuse leg triangle congruency relies on the fact that the angle opposite the hypotenuse is a right angle. So in this example, we see that C and F are both right angles. And we see that side C and side F are congruent to each other. In order to have this, we need one of these other sides to be congruent to each other. So where A is congruent to D, then that's what our hypotenuse leg triangle congruency looks like. An example of how they might try to trip somebody up is where they put the two triangles together like this. So we have right angles, we see that they have sides in common, and that common problem that students have, the shared side. So the shared side is congruent to itself. SQ is congruent to itself. So with that, we have a right angle, a side, and congruent hypotenuse. So we get our hypotenuse leg triangle congruency. In a second example of how they may try to trip students up, K is described as the midpoint for JL, which means that this side and this side are congruent to each other. K is also described as the midpoint of MN, which means that this side is congruent to this side. So we see that across from the 90 degrees, those sides are congruent to each other. We see that we have a side that is a congruent length, and that both triangles are right triangles. So the hypotenuse leg triangle congruency works here. Remember, math rocks with a capital M.